Hello, and welcome back. Today we will introduce the derivatives and integrals of transcendental functions. What I mean with transcendental functions is that they transcend the normal algebraic line system, parabolas, etc. And the first ones we're going to start are logs and exponents. So let's get right to it. The first most important thing you're going to need is the derivative of the following function, ln of x. Now, the derivative of ln of x is very important because we can actually come up with different things due to this. So this is actually 1 over x if you already know it, but we're actually going to derive it. So it is 1 over x, but for now let's forget about it and we'll see how we're going to derive it. Using the limit definition, we write limit as h approaches 0 of, in this case it'll be ln x plus h minus ln of x divided by h. Okay, so here the trick is just to simplify it. We're going to use log rules. So you see how there's a subtraction here? Subtraction of logs with the same bases, in this case log base e, natural log. That means we can divide ln of x plus h divided by whatever was over there. It's like that. Everything divided by h. Now let's go into the inside of the log and simplify things together. Ln x divided by x is 1 plus h over x, 1 to the 1 over h, and of course the limit as h approaches 0. Okay, good. Now there's another important log rule, and the property states that whatever is in front, the coefficient in front of the log, can be brought into the power, right? So here we can write limit as h approaches 0, ln 1 plus h over x to the 1 over h power. Okay, now this is the most critical part. We're gonna have to think in an abstract manner. Okay, so let's take a look at this limit right here. It's telling us h is going to approach 0, and right here 1 over 0, or 1 over an approximation to 0, gives us something that does not exist. It's inconvenient. So let's actually rewrite that. Having the same idea, let's find an equivalent for h. So h is going to go to 0, right? Okay. Now 1 over, let's say, a variable n, as of course limit as n approaches infinity. Now why did we just do that? Well, when n goes to infinity, mind you, the number in the denominator gets very big, and as that number increases all the way to infinity, it actually approaches 0. So as long as these limits are true, this equation also becomes true. So now we can actually make a substitution. Here we see 1 over h, so 1 over h is the same thing as n. We're going to make that substitution. So now it'll be limit, we're going to make everything into n now, as n approaches infinity, of ln 1, okay, we're going to leave a gap because we're going to change that as well. 1 over h we determine to be n. Now right here, h over x, we can just rewrite it using this property right here. So h equals 1 over n. We can just simplify it in there directly. That's 1 over nx. Okay, we're almost done in this derivation, but you might be thinking, well, this does not look like anything I recall. Well, let's actually keep on. Limit as n approaches infinity. I'm going to make a slight modification. We're actually going to lift the x up there into the numerator, and can be done rewritten like that, so on and so forth. 1 over x divided by n is the same thing as 1 over nx. So I've done no change, I just rewrote it. And now I did this because immediately looking at the inside portion, it reminds me a lot of what the e looks like. 1 plus 1 over n to the n, limit as n approaches infinity. Well, that's e. Now I did that because this important number is very important, because it determines what the power of e is going to be. For example, if this is 2, this is going to be 2. If this is, let's say, a variable x, this is also going to be x, e to the x. That's why I did this right here. So we see this inside right here is going to simplify to what? We see this number 1 to the x, so that's going to be the power. It simplifies to e to the 1 to the x. Of course, ln, limit, oh, the limit has been applied already, so we can get rid of that. And just take the log of this, and voila, 1 over x. So that's actually the derivative of ln x is 1 over x. We actually derived it, and now it's in our toolkit.